So yeah, I think from the last sessions we covered primarily on the VPC side of the AWS, primarily networking. So we looked at uh, yeah, this is overall product landscape. It's a subset, not a complete set, but very important components are covered in this set. But at least this covers starting from availability zone to networking side to compute storage, application services, analytics, databases, security, operations, development, libraries. So out of which I think we are started with networking area. Prior to that, some areas of compute also we covered, not all, but some areas of compute we covered. So currently we are focusing on the networking area, and we started with availability zones, primarily the regions and availability zones. Uh, so we understood what is region. Region is nothing but a geographical location. Availability zone is a data center within that region. So generally the data centers will be separated by miles at least, but the regions are like geographies. So they're very distant locations. So generally, if you look at the architecture, there will be cloud and there will be a lot of regions. Under a region, there will be at least availability zones, minimum 3 availability zones will be there per region. And yeah, of course, generally any AWS resources will be under that availability zone. And then we looked
Uh,
at,
Sam, one question, quick question.
yeah,
What is the minimum distance they are maintaining between availability between the zones?
I mean, there's no hard and fast rule, but generally 100 miles minimum. That is what is as per the documentation. But again, there's no hard and fast rule that it should be 100, but
Okay,
generally 100 miles away. So,
okay, thank you.
right. So and then AWS region, yeah, there are a few considerations that we discussed. Again, not all products are available in all regions, so that's a very important consideration. So before you select a region, so generally, yeah, they'll pilot first. Generally, especially the new products, they'll pilot in few regions first, based on the responses and stability. They'll be generally deployed in other regions. So that is something you should keep in mind before you select a region, and cost aspects and legal and compliance requirements. All these things you should consider in mind before you select a region where you want to uh, create a resource in AWS. And then yeah, we dive into AWS VPC. VPC is primarily the networking component, which is primarily helping you to create an isolated virtual network. Then we discussed about primary. It generally helps you to create a data center inside on a cloud. So where you are isolated within that network, all your resources within the network are secured. And there are a lot of, we also discussed about the use cases, public facing, multi-tier web application, disaster recovery requirements. Then so these are various combination scenarios where you consider VPC. So again, go through that in detail. VPC scope, then we also saw that generally the VPC is spread across availability zones, and also within availability zone there are subnets, and each subnet there are instances. Generally, that is a hierarchy. But just important thing that we need to remember from exam point of view is VPCs generally they spread across availability zones. So that is very important from exam point of view. So they might ask questions here, and also generally the VPCs will contain subnets, but the scope of subnet is restricted to availability zone. So again, this also from the scope is very important to know. Um, so for complex, for simple use cases, generally for POC kind of thing, so for people who are not comfortable networking area, so they can quickly go with the default VPC. So where default VPC is something AWS is giving us, so that you, for small POC purposes, you can use the default VPC setup, so that you don't need to worry about creating a VPC subnet availability zone. So all these things, all defaults will be given, and then you get one VPC setup ready for you, for especially when you create an EC2 instance for a virtual machine, for example. So yeah, you can generally go with default VPC, but generally in production purposes, default VPC is not suitable. We will go with custom VPC definition. So in that case, we need to know how to create VPC and how to create a subnet, availability zones, and all those things. So you should know in detail about every component inside VPC, so that you can create your own custom requirement for your own project or your own client. So VPC components, we discussed about the various components inside VPC. Generally, the subnet. We discussed about the subnet is again a logical partition of your VPC, and primarily it will the IP range makes that partition difference. So you'll have public subnet and then private subnet. So public subnet will have access to internet. Private subnet no internet access. A route table again rules. It's nothing but a firewall. So you'll have a firewall set of rules saying this resource will have access to this network, this device. So all those and which port they will have access, and all those things will be defined in routes. And for as I said, like public subnet will have access to internet. So the internet is for in public subnet you need an internet gateway to get that internet access. And we also discussed for private subnets there is no internet, which means for a private subnet, if you need temporary internet for some reason, so then use NAT gateway. NAT gateway will allow internet to private subnets primarily. So public subnet is always internet gateway, but private subnets if you need then NAT gateway is a solution. Again, VPC endpoint. Again, you want to privately connect your VPC to other AWS resources. Then you use VPC endpoint, and which is backed up. This VPC endpoint is backed up by private link. CIDR notation. So just basics about IP addresses. This is very important to know before you're entering into the networking area. So IPv4, what is the convention? So uh, I think we discussed on what is the meaning of /16, /24, /28, and also we discussed about IPs shouldn't overlap across the subnets or even for VPCs. So it is very important to keep a track of the IPs. I mean, primarily the networking person who generally he will keep track of all the IPs and for various VPCs and with various subnets. So that way, when a new VPC has to be created, then he will ensure that the IPs should not are not overlapping. And we also discussed about AWS will have reservations for IPs. So even though you let's say you created a VPC with this so a VPC or subnet with this range, so generally you'll get 4096 IPs in this range because you give /20. So you get 4096 IPs in that. Generally, the first four IPs in the last one will be generally reserved for AWS. Of course, the rest of it is I mean, you can use it for your requirement. We also discuss about internet IP, the overall VPCs, and inside that we have subnets. So it is like a bigger VPC is a bigger compartment in that you are splitting into smaller chunks. That is what is subnet, and the subnet will have a range, and it is like you are splitting the bigger /16 into smaller range of /20 and /20, for example. And inside each subnet, you will have all these IPs will be allocated to some other resources of AWS. For example, EC2 is one case. EC2 and EC2 or instance or all these are all synonyms. I mean, whenever you say instance, instance or EC2 or VM, so all are same. We're talking about the virtual machine. Generally, very common thing is to use these IPs for EC2 instances. But yeah, we can use if you have other resources also from AWS. Everything will need an IP. So this IP can be consumed by any of the AWS products. But yeah, they should be if they are defined within the subnet, so they will not be accessible outside. If it is a private subnet, then you will not have access to this instance outside. So it depends. The subnet is public or private. So that it depends on that the boundary. So generally, public subnets will have access to internet, but whereas private subnets will not have access to internet. Then we also discuss about IPv6 addresses. Since IPv4 is the range that it can extend is less, so kind of IPv4 is dying. So at least we are running short of IPs. So we are IPv6 is you get a broader range where, for example, you can get this many addresses for /56 VPC in IPv6. Whereas /64 you get this many addresses, so which is like very wide number of addresses that you get. So yeah, but yeah, the point is AWS supports IPv6 even though it is very new. AWS already supports IPv6 addresses. And we also discussed about internet gateway. Internet gateway is where you get the public subnets, you get internet. So that is where the primarily VPC will be there and route table. And this outside, generally this VPC is secured. So, for example, for this, the resources inside VPC, if they want to have access to internet, so then there will be an internet gateway that will be deployed on this VPC. Only then the resources inside can get access to internet. So, so for that, the mapping that you need to do is in the route table, you in the target especially. Once you create a VPC, sorry, you create an internet gateway. So let's say the internet gateway is IGW ID. So then you come to the route table and add this mapping. The destination is zeros, which means like all. We're giving all, and then you're associating the internet. So which means like this rule says all the devices, like it's like star. Okay, 0.0.0 is like star. So all the resources can have internet. That is the meaning of this line. So this entry is what you make in route table. So that way all the resources inside this can get access to internet. And then we also discussed about security groups and actors. Generally, these are all. Generally, the security groups are again from the name itself, it's meant for security purposes. Your security groups are at instance level, whereas the knackers are a higher level, which is a subnet level. Very important from exam point of view. Definitely, there will be one or two questions under this category of security groups and knackers. So here, very important thing from exam point of view is they will give a scenario and then they will ask which security group is applicable. So generally, if there are any questions related to instance level security, then you should always associate to security group. Whereas if you want the based on the scenario of the question, so it will be mostly the questions will be scenario based. This basically the scenario talks about something to do with security group at a subnet level, but not at instance level. Then so then you should consider MACL. So yeah, we discussed about the differences. Very important difference is very common question that we get is this security group stateful versus stateless. So so yesterday I was going through some exam questions and so there were a lot of I mean at least the questions are a bit tricky, uh, but uh, but yeah, you can easily eliminate two out of four. So, but the other two will be confusing. So the questions, especially one question which I faced is on the stateful concept, where for example the incoming port is open. So by default, we we should just keep in mind that the scenario that is given is like security group is used and the incoming port is enabled. So, what should user do to enable outgoing port? So, so the answer is he no need to do anything. So, one of the options is no, he no need to do anything because if incoming port 80 is enabled, security group being stateless component, outgoing port is enabled by default. So that is what a stateful means. So yeah, so like yeah, it'll not be like po- point is like you need to remember the concept, but I think the questions will be they give a scenario and they will try to see whether you're trying to apply this scenario there, whatever you learned. So that is something we need to keep in mind. So the question will not talk about stateful or anything. So it just says security group and port incoming port 80 is open. And what you should do to enable the outgoing traffic. You don't do anything because that is already enabled. I mean, so this is something where kind of tricky questions will come like this. Yeah, but yeah, this point is security groups are stateful, so you need to open if incoming is open, outgoing is not required to open. And security group is applied at instance level, where a NACL is applied at subnet level. Then security group is only allow operation. Here both allow and deny in NACL. In security group, all rules are evaluated. There is no order, but here rules are evaluated in order and applied to instance only. The security groups are applied at DC to instance only, but whereas NACLs are applied to all the instances. Security group is generally the first layer of defense, as you saw here. This is the if there's attack on this EC2 instances. So generally, the security groups will help you to prevent any incoming traffic to this from outside. So so that is first level of defense for this EC2 instance. And the second level of defense is this networking layer. So no one can. This is already bounded on a network. So this is giving an extra layer of security to you. So yeah, the second level of defense is NACL. So yeah, so that's about the security aspects.
Shyam?
Yep.
Just quick question. On this slide, apply to all instances which are associated with an instance.
Yeah.
Can you just elaborate on that? I think, are you meaning that once I have an access to an instance, by default, everything within the VPC will be given access?
No, I mean the rule that is applied at a subnet level. From this diagram, you can see this. This is the rules. Whatever you create at this level is applied to all the instances that are inside this network. So it is not specific to an instance. So it is common rule for all the instances, not just one. But whereas security group is just specific instance, or you can apply it as a group also. That is also possible. But this guy is always to all, applies to all the instances under that VPC. That's what it means. So, for example, you are allowing port 80, then it is allowed to all the instances under this this network. So this is very dangerous also. I mean, doing it that way. So you should be very careful because the rule whatever you're applying is applied to all. For example, you want to block the traffic only to this. For example, you want to deny incoming to port some, let's say, a database which is there inside. Let's say you have a Oracle database is inside. Oracle database runs on 151 or 23. I don't remember that. So 1521, I guess. So that port. So so if you're blocking that 1521 at here, then all the instances which are having Oracle instance will be blocked, for example. So yeah. So that is the meaning. So the scope is what is important. The scope is to all. So that is what it means.
Okay. Thank you.
Yeah. Right. And yeah. Then NAT gateway. So this we saw primarily. Like especially for private subnets, the scenario is that the private subnets generally will have databases because databases shouldn't be exposed to internet. So there in public subnets, you have all the layers like web servers and other areas where you want to expose to outside world. So they will be deployed in a public subnet and they will have access to internet. But whereas the databases will be generally deployed on a private subnet. But for some reason, when you say private subnet, then they will not have access to internet. But if you want to expose internet on this private subnet temporarily, let's say for a patch upgrade scenario to database. So for this, let's say you want to go to internet for momentarily, then the solution is NAT gateway. So you will create a NAT gateway. Very important thing is this NAT gateways are not created in private subnet. Again, very important exam question. So the NAT gateways will be created in public subnet, but they'll be associated to this private subnet. Like that. The association is happening via this route table. So here you're telling the rule that IGWID and then here you're telling the NAT gateway ID for this private subnet. You're telling that for this private subnet, for the target is NAT gateway. So then any traffic that is coming from any internet traffic that is required, any hit coming from database, so it will go to this here and it will identify that the target is NAT gateway. So the call will go to NAT gateway, and from here this will have access to internet because it's in public subnet, and then it can go to outside world to get via router and then via NAT gateway, and then it will go out and get the internet. So that is a process. So the primarily the NAT gateway is summary, one-line summary, NAT gateway is primarily to get internet for private subnet. So that is an use case. Then we also discussed about the VPC peering. Generally, the VPCs are bounded. They will not have access to. I mean, one VPC component, let's say EC2 inside VPC A. They generally can't talk to VPC in the EC2 instance in VPC B because these two are different networks, different VPCs, so they can't talk to each other. But there will be requirements where two VPCs need to talk. For example, in that case, VPC peering is a solution for you. So generally there will be a VPC A, or the owner of this guy will send a request, and yeah, so this guy, the owner of this guy, will accept that request. So that way this connection is active. Then you can access from this to this and this to this. And again, we discussed about very important exam question, translative pairing, a very common question that can come. So generally, no translative pairing is allowed. So what it means is, yeah, AB, BC, but not AC. So meaning there is a VPC A, VPC B, there is a connection, VPC pairing. Similarly, A is connected to C, VPC pairing in between. But so it doesn't mean that B and C can talk to each other. B and C also would require a VPC pairing. So yeah, there's no transitive concept applies here. Okay, so we also discussed about the direct connect. This is again primarily comes in the scenario of data center versus cloud combination. So you have an on-premise data center on the right hand side, and you have on the left hand side you have a public cloud, I mean AWS. Now these two guys want to talk to each other. Then yeah, you need a direct connect component which is required in between. So yeah, the advantage of direct connect is that yeah, this direct connect is involves not just the AWS public cloud and your the customer. There is a third party person who will be also in between, play a role. Generally, he's a uh, is a vendor of AWS, and we need to involve him, and then he will create this network for us, and then you can do the transfer. But that a very important exam point of view, the questions that will come is the generally here this is a dedicated network, and also the connection options that you get are 1 Gbps and 10 Gbps. These are the two options that are available in this direct connect. And then the concept primarily from exam point of view, the questions what anything if the scenario talks about primarily comes on a scenario based question where there will be an on-premise setup and they want to talk to cloud, but they don't want to have an internet in between. So what options you have? So one of the options is different direct connect. So this link that is being established will not be on a public network. So which means there will be a private line that will be created. So that way you get that speed as well. And generally, these use cases we saw, which is primarily direct connect use cases, are primarily to transfer on-premise. We have large data sets, especially we're talking about the migration scenario. Let's say you are now moving from on-premise to cloud, and so which means you need to transfer a lot of data from your on-premise. Maybe for first 2 months is like a lot of data transfer across happens from, let's say, on-premise database to public cloud database. So you're talking about huge volume of data. So the transfer of data or internet is like will be very slow. It depends on the internet service provider. But bandwidth is generally not sufficient. So in that case, so that's one use case where direct connect you temporarily um, deploy this direct connect for maybe 1 or 2 months till the migration completes, and then you can disconnect. So you don't have to pay if you're not using it. So similar like any other AWS products. So that is one very complex, very common use case where we have large data sets to transfer. Then temporarily deploy direct connect, you do the data transfer and then close it. That is one very common use case. But apart from that, the other use cases are real-time data feeds that we get. There are where you're transferring a lot of voice and video feeds in real time. So then you need direct connect.
Sam, in this case, it they need to have the dedicated connection laid out, right, across.
Yeah,
Uh,
that is
is
that
that
is.
available? Is this available for all the customers, or is like
Oh yeah,
they have to have a dedicated line laid out for all the entire network, right?
correct, correct.
Otherwise, they cannot offer the direct
Exactly.
connect.
That is one of the drawback in this direct connect where I think it's coming the next slide where there is a
Okay.
region it is not available in all the locations yet. So there's a list
Okay.
of locations where it is available. So I can see that here. So anyway, so as I said, like yeah, it is not for all the regions it is enabled yet, but wherever we have um, the regions are very limited at this point, but every day the list is growing. But
Oh, okay.
yeah, for example, in India, let's say you have this many vendors who can support this. We're very limited, for example. Mumbai, we have at least some five. Singapore, we have few, and Sydney, we have few. Tokyo, so yeah. So in US also we have yeah, the US is Virginia side. So yeah, so again, this depends on the location. So if you're not in that location, then yeah, you'll not be able to support. And also this vendor is very important for you because this vendor, this is all the vendor names that you're seeing here on the left hand side. These vendors is where you need to bring in contact. You should come in contact with these vendors to get this connection happen. So
Okay.
yeah, so that is what it is. So
Okay. Thank you.
right. So yeah, so that's about this. Yeah, generally the flow is that you will pull direct connect, create a connection request, and then you download a letter of authorization from AWS. So till the first three steps you do it in AWS console, and after that is all offline, where you need to take this letter of authorization from which is downloaded from AWS console, and you should take that to the partner, whatever I showed you in the list, and then you should have a connection with him and establish the connection, and then he gives some details and where you need to update it back the console. That's how this connection happens. But this step is completely offline. So you need to that can take maybe 1 week or 10 days. It depends on the vendor there. Okay. So then we also discussed about the VPC endpoint. This VPC endpoint is again VPC is bonded to it is like a data center. So you'll not other guys from outside this network can't access this guy. But there will be common requirement where uh, a product which is inside a VPC want to talk to a product outside this VPC. So, for example, S3 is one of the very common storage platform that is used by all the most of the AWS products. Will talk to S3. This is the basic storage, free store, I mean, cheap storage option provided by AWS. So so in that case, if let's say VPC endpoint is not there, so you generally this is all boundary, right? So you need to go to public internet and then come outside of AWS and then talk via internet. You need to talk to AWS S3, which is like a lot of traffic outside going out of your network and coming inside. So just to avoid that, we have something called VPC endpoint, a product in AWS. So it just connect. So you just connect these two guys. For example, this product and this product connect via VPC endpoint, then you're good. So this traffic no need to go outside and come inside. So you can directly talk to this guy. So again, this all um, primarily coming under category of reducing the network traffic going out and coming in. So that's where this VPC endpoint will come into picture. Again, this is not on internet. This connection is over private connection, so which means no internet. So yeah, so that's very important to know, right? So, and then we also discussed about the interface endpoints, something called ENI that also plays a major role. The Elastic Network Interface. So this guy will act as an network interface point. Um, so to transfer the, let's say this guy in a EC2 instance wants to talk to, and this EC2 instance is in a subnet. So which means it can't. Let's say this guy wants to talk to Kinesis, another product of AWS. So again, the same situation. if the if this interface endpoint is not there, then he has to go out of the traffic and then come back to and talk to this guy. But the interface endpoint will give you a ENI, so the VPC similar to VPC endpoint. So this guy will talk to this guy directly. Again, this is all reducing the network traffic going out and in. So, and then we also discussed about this interface endpoint is again a product that uses private link as underlying technology. Again, this is again private link is very I mean this AWS is pushing this product very. I mean, they're trying to introduce this private network everywhere because so that way all the products are secure. So that way this product is getting a lot of traction these days. They're trying to integrate private link in all the products as much as possible. But yeah, the integration is ongoing. But that's why this product, for example, will not have this connectivity to all the. It is not connected to all the product set. I mean, the interface endpoints, AWS services, it has some restrictions. So we have some products only using which you can talk, you can connect. So the point is that if you want to use interface endpoints, just keep a note that whether the target product that you're trying to communicate is already supported by interface endpoint or not. So there is an AWS documentation where they give. This list is growing every day, but yeah, you need to check whether your product, for example, these are the various products of AWS where you can whether this product is outside your VPC, then you can talk to these products. But again, this list is not final. I mean, not all products are coming under the integration yet. So this integration is not possible to all the products. So yeah, just keep a note on that. And then this gateway endpoints is another combination where it supports only S3 and DynamoDB. If these two are the products that you want to talk to, then you can refer gateway endpoints. You can use gateway endpoints. Again, for us coming under the same category, there's a gateway S3 is outside, and your EC2 is inside, and then you can use gateway endpoint and the advantage is that this is free. This gateway endpoint is free, but the limitation is that it has only S3 and DynamoDB. When it's a free, there will not be any charges for using this gateway endpoint. But whereas the interface endpoints, they have usage charges, but whereas this is free. But only limitation is that this supports only these two products. So, but whereas here the list is growing, so you saw that very big list coming out, right? So that is the difference between interface endpoint and gateway endpoint. From exam point of view, the question could be something on you want to talk to S3 and you want the cost is a very important factor. So then obviously gateway endpoint because it is free. But you're talking about talking to Kinesis, for example. So then it is not coming under the gateway category. So it's not supported. So obvious solution is interface endpoint.
Any restrictions on the speed between both?
No, it is all through private link only. So all inside AWS. It's not going outside. So the speed is. I mean, there will be difference, but it doesn't matter actually. It will get a very good decent speed because we are not going out of internet. So it's all within the network only. Right. So as long as it is the outside region, then it makes a difference. But as long as it is within availability zone, it should be even faster.
Okay.
Yeah.
Shyam?
Yep.
Yeah, just stay on slide for a minute. Just a quick question. If there is a need to do balancing, if it is a point for ELB, where the ELB will be coming after the endpoint or before the endpoint? Where you know?
Yeah. ELB is something. When you're talking about load balancer, which you'll be covering today. Generally, the load balancer will be sitting above this VPC generally, and let's say this load balancer can talk to VPC or it can talk to any other IP directly. The IP need not be in VPC, for example. Yeah, but sorry, I forgot it. Can you come again with a question?
Yeah, I think if you're going to cover ahead, I think I don't want to confuse the group. I think we'll take it later.
Sure.
If you have already touched upon, I thought they just want to clarify it. But if you're going to cover it, we'll move on.
Yeah, I think that is today's topic. So we'll cover ELB.
Okay, thanks.
Yeah. Okay. So we also looked at flow logs. Again, primarily it is not a uh, dedicated product, but it is a debugging tool, primarily for a cloud engineer to debug the network in and network out traffic. So this is one tool that that will be very handy, where this will primarily help the capture the IP traffic information going in and out of VPC. So yeah, very common problems is connectivity issues. I send the data and it is not reached. So where is it? Why there is a delay? So all these common questions that will come in real time. So generally the cloud engineer will look at this VPC flow logs to get more details. So the common things that will help you to diagnose is like connectivity issues, intrusion detection, then anomalies, and again complaints. Again, any complaints reports. They want to see the network out traffic, how secure it is, and all those audit-related questions. Generally, all these VPC flow logs will help there. So it is nothing but a log file at the end. So it will have a structure for this log. So they have to cover a lot of things. So it will be all space separated log entries. For example, version, account ID, interface ID, source address, destination address, source port, destination port, and what protocol, what packets, what bytes, start date, end date, action, status, and all. So this is how your log will look like. It's one file, one entry covers one traffic, one data packet which is being transferred over the network. And VPN, we discussed about this the last session. Uh, VPN is primarily for requirements where on-premise and cloud, and they want to talk to each other, and they want uh, an extended data center is the kind of requirement. Like they already have customers already having a network, and they want to well, they already have a data center, but they want to have an extended data center where any employee of this organization can directly access those resources. If that is a requirement, then site-to-site VPN is your point. Is your point to look at. So generally, you create a VPN connection and you get an extended data center. So the employees of here can directly talk to the employees of this organization can directly use without connecting to a public network. So they can they can do the data transfer or encrypted tunnels, which is very important. So exam point of view, they will ask um, this what is the security mechanism used in VPN? So the answer is encrypted tunnel over IPv6. So this is very important point. It's very common VPN concept and nothing specific to AWS. But yeah, again, the questions can come under what are the encryption methodologies used. Also, it could be a very common question. There are a lot of encryption methodologies are there. Mostly the algorithms are like AES and A256. So a lot of SHA-based algorithms. So these are all various security algorithms which are used inside. Um, so the site-to-site VPN is primarily an external data center kind of a use case requirement. And other option under VPN is client VPN. So this is another category. So where this is what we generally use in our organizations as well. So as an employee, as an end user, you will have a VPN, some VPN client installed on your laptop, and using which you connect and then you are connected to AWS network. So yeah, this client VPN endpoint is like any free VPN software. AWS supports all the popular free VPN softwares, and also it has its own software as well. So yeah, that is a client VPN requirement. And we also discussed about the site-to-site VPN. Again, yeah, this is what I was talking about the security algorithms, the AES 256. Yesterday I was looking at an exam question where it talks about what algorithms are used. So then after that I try to understand what is this algorithms and also. But yeah, AES 256, SHA-2, and a lot of DH groups algorithms. So these are all primary and IPsec site-to-site tunnel security mechanisms used inside. But the point here is for There will be two VPN tunnels which will be used. Again, this is primarily for redundancy purposes. Like for example, if one VPN tunnel goes off, there will be always a backup. So this is your cloud, and this is your on-premise, and they're connected via VPN. So let's say from your on-premise you want to connect to a EC2 deployed in this VPC. So you generally connect to VPN, and then you directly access the IP of this EC2 instances from your on-premise, and that connection will go via a private tunnel. Either this one or this one, any of one will be primary, and other one will be secondary. So yeah, it will generally go via primary. Primary is the only the secondary will become active. So it will go via primary and then connect to your EC2 instance over the network. And these are the use cases. The advantages, highly available, because this is all completely managed by AWS. So that is very important takeaway. They're high, so the high availability of this VPN software, and the the software maintenance of this, upgrades of all these things are all managed by AWS. So you don't have to worry about all these things. So yeah, so it's highly secure, robust. Then for example, if you have an extra requirement where the speed that is provided by site-to-site VPN is not sufficient, then you have an extend option called accelerated site-to-site VPN. This gives more performance compared to the traditional site-to-site. This is more accelerated site-to-site, where you're bothered about like your networking speed and other things. Then you can also go for accelerated version. Again, so it also internally uses a concept of AWS Global Accelerator. This is again another product of AWS. So this generally intelligently routes the traffic to the nearest AWS network. I think in my last email, I was telling the differences of giving the differences of the exam has two versions. I mean, the two papers. The current version is a kind of older version where it is expiring by June, by end of June. So which is like 1 month from now. So, but whereas the second paper, the latest version, which is will be active. It's already active now. So it's in beta phase. You can take the new version right now. But yeah, after June, from July 1st onwards, the new version will be live. So that's the only option for you to take the exam. So the point why I'm telling that, because AWS in the new version, the AWS added more new concepts for in the scope for the exam. So one of this product is AWS Global Accelerator. So yeah, so this is not there in the older version, but yeah, this is in scope in the newer version of the AWS exam. So yeah, that's why I thought of telling you that. So yeah, this AWS Global Accelerator is nothing but intelligently routing the traffic to the nearest AWS endpoint. So it based on, since especially when you need an accelerated setup, so then internally it uses AWS Global Accelerator, and it will intelligently identify to route the traffic faster than the normal version. So yeah, so there again we saw that site-to-site use case are extending your corporate network and secure communication. Yeah, so site-to-site VPN, how it works. So in AWS console, you first go and create a transit gateway or virtual private gateway, and then you download the configuration file. Accelerator option is an optional component. If you need a very high speed, then you go for accelerate. Otherwise, it's an optional component. But yeah, then after that, you download a configuration file, and then you use transit gateway or virtual private gateway, so using which you will push this data out. And this transit gateway and virtual private gateway are the entry points of your boundary. That is, so for example, in customer gateway, you'll have the customer premises, the boundary, the last boundary where data goes out. The last boundary is the customer gateway, and here the first entry point in this VPN setup is your virtual private gateway. So these two are also important for you to set up for VPN. So that is again, this is one-time setup, but but these gateways are also equally, we should set up first, and then only you can create a VPN, and then you connect these two. That's how the process is. That's where I was telling this diagram. You need to, once you create a site-to-site VPN, you also need to establish your transit gateway and virtual private gateway. Right. So yeah, and then this is VPN client scenario, the second client VPN. So this is the end user trying to connect to VPN, and then he is directly inside VPC network, and yeah, he can do the operations, he can access all the resources. Again, here at this point, authentication is taken care, where let's say generally you'll have this employee is part of the organization, so you'll be already having some LAN user ID and password, which is integrated to an Active Directory or any other equivalent components available. So this has an integration to all the common integration points, so like Active Directory or LDAP, whatever. So and then it will also, so here the authentication is done at first level security, the authentication aspect. The once the user is authenticated, then the authorization aspect, where this guy is having access to which subnet in AWS. So that authorization part is done at this level, where it's based on the network where he is having access at security groups. So based on that, he'll be routed to access the resources or not, based on the permissions that he has on security groups. So again, more security aspect. When we saw this use cases, advantages we saw, yeah, and then use case also we saw. Especially this VPN, client VPN plays a major role. Where you can quickly scale the remote access during unexpected events, where employees are allowed to work from home. Perfect use case of this Corona situation, where you want to ramp up your working from home employees. Suddenly there's a spike up of work from home requirements, and then you need to add more VPN connections. So AWS is a perfect, cloud is a perfect example where you can just on a button click you can create VPN VPN resources. But whereas in on-premise there will be always a restriction in terms of the physical hardware, so which is not possible. But yeah, so this is a perfect use case for VPN requirements, where cloud makes a major advantage. Yeah, and then you can easily revoke access to temporary workers. Generally, contract employees, like let's say there will be contract employees where they will work for 6 months to 1 year or 3 years. So temporarily you can give access, and then quickly you can revoke it. So all the VPN client connection can be revoked in a minute, for example. So it is very that easy. So you can create and remove. So it is easy to manage stuff over the cloud. So yeah, then yeah, this how it works. So generally, you create a client VPN connection, and he will give all the where and all he should have access, the privileges and all. You will create saying this subnet he should have access and all those stuff. Then end user will, and all the authorization rules will be added. Um, then enable the connectivity to all the networks and rules. This is all the configuration part. As an admin, any new employee is coming to the organization, so he has to do this step. Then you will be giving the user ID and password and the VPN IP details to the employee, and the new employee will download or install a free VPN client, and he can connect. That's all. So then transit gateway. This is a very new product from AWS, where the scenario where you're a growing up company, and then you're a global company, and then suddenly your operations are growing, and you're maybe adding more companies inside your company, or merging a lot of companies into your company. So basically you have a lot of VPCs maintained, and suddenly this VPC counts are become so huge, and you need to integrate all these VPCs. So we're not talking about it is easy to manage 4 to 5 VPCs, but imagine we're talking about hundreds of VPCs suddenly. Then managing that is very difficult. The traditional approaches is that you create a VPC pairing between these two guys, but imagine these two VPCs, then you need one. Then 3 VPCs, we have a formula here. So how many VPC pairings you need between two VPCs to manage? So the formula is n into n minus 1 by 2. For example, if you take two, let's say, yeah, so basically two VPCs you want to do. So how many VPC pairings you need? One, right? So 2 into 2 minus 1, 2 into 1 by 2, which is 1. So you get one VPC pairing. So likewise, so this formula, applying this formula, 10 VPCs, then you need 45 pairings. 100 VPCs, you need 4500 VPC pairings. It's crazy. So it's not difficult to manage so many VPC pairing connections. I mean, we're talking about a global company here where 100 VPCs are there, and he has to manage it. So, and it's not just VPC pairing. Along with that, VPN connections also. This company is also having an on-premise setup, and they're on-premise, and then should talk to cloud. Then we're also talking about the VPN connections between them. So they also grow exponentially. So for such use cases, AWS has a solution called Transit Gateway. So this works on a concept of hub and spoke model, where um, where like two VPCs won't talk. All VPCs will talk to Transit Gateway. So it's a single point where you can do all the rules and configurations. Everything can be done in one place. Again, it has all uh, the all the typical cloud terminologies like scaling and redundancy, and all those things are available in this Transit Gateway. So it's not a single point of failure, for example. But the point is, all VPCs will talk to this guy. And also there's only one VPN connection required to a customer. So that way, we're talking about one VPN connection and one place where you need to configure everything. And so that's all. So you don't even need VPC peering. So it's easy to manage. So that is the concept of the Transit Gateway. That's where it plays a major role. And yeah, generally this is generally it is costly because it is having a lot of advantages. But generally this is for a bigger organization where they are spread across and they're global, and a lot of data set. They have to connect a lot of data centers. So all the kind of a bigger companies are we talking about? Transit Gateway plays a major role. Okay, so far is all recap. So recap itself took 1 hour. So yeah, so I think let's talk on the current topics. So
So
today,
Shyam,
yeah, I think
you
logically take a,
are you recording now? So stop it. So at least
yeah, sure, that's a good.